Yeah. So yeah, ready to kick off where we left off on Monday. So where we got to was in designing the smoke detection system. So the requirements around that, and we got up to the spacing of the smoke detectors. So the area of the NCC that covers all of this is the services and equipment, and we've got our specification smoke detection, specification 2.2a smoke detection systems. So in 5, 6, 7, 8, 9 buildings, the smoke detection system complying with clause 4. So head to that. Smoke detection system must, subject to C and D, comply with AS 1670.1. So here we have AS 1670.1 ready to roll. And activate a building occupant warning system in accordance with clause 6. So that's something that you've, I think I mentioned that on Monday, but that's something that's got to be mentioned, that you have a smoke detection system which activates a building occupant warning system, and then you can say compliant with clause 6 for the of section E for wherever we are, section E within the NCC. So we go through that, and beyond that we had clause 4. Go to that one. In kitchen and other areas where the use of the area is likely to result in smoke detection causing spurious signals. We've got in any other detector deemed suitable in accordance with AS 1670 may be installed, providing that smoke detectors are installed elsewhere in the sole occupancy unit in accordance. So in kitchens and things like that, you can use a different type of smoke detector, so like an ionisation smoke detector or so for those areas where you're going to get where it's going to be tripped off by somebody burning their toast, etc. So that's another note that can go in if you specify a smoke detector within the kitchen areas. But in regards to meeting those spacing requirements, the spacing requirements are within Australian Standard 1670.1 that covers installation of smoke and heat detectors, and under section 5.1 we've got section 5, smoke and carbon monoxide fire detectors, spacing and location of point type detectors. Most of this is not specifically relevant to us. We've got things like where the ceiling or roof height is more than 12 metres from the floor. The detector type and location may require additional engineering considerations, but we're not 12 metres from the floor. Many of these aspects are not relevant to us. What is relevant, however, is, where we've got it, 5.1 in 5.12. So for level, yeah.
Where do we get information about what type of detector we're choosing? Like you've got optical beams,
yes.
you've got aspirators, you've got the ionised, you've got the standard.
Yeah. So in here you're given these two options. For we're given two options of smoke detectors. In there you can choose which one you want. So I'd be going like for optical beam smoke detectors, the distance between beams shall not exceed 14 metres and not more than 7 metres from the wall. So that allows you that larger spacing. So I'd be choosing those above the the point detector, which the nearest detector does not exceed 7 metres.
So what's the aspirated system?
Aspirated system, I don't know. Haven't looked into the aspirated system. I think that's actually what we've got up here. This one up here.
Yep.
I think that's an aspirated system. Exactly, but I don't know how they work.
Right.
And so the calculations for that. So aspirated systems shall be arranged that sampling points have the maximum spacing as that required for point type smoke detectors. So it's same spacing.
Yep.
So so you can choose either the point type and the aspirated, which are 7 meters, or the optical beam, which is 14 meters. Either way. As to the performance of either those three types, I don't know. If you wish, so many of these aspects, as in the workplace, would be covered by a fire systems engineer. They would design the whole system. So you can say this, we want the fire systems engineer to cover all the hydrants, hose reels, fire safety, exit points, and fire warning and fire detention systems. And then they cover all of that. So you're not expected to understand a great deal about this yourselves. I don't understand a great deal about any of these systems, or just some components I know a bit about. Because in the office I used to work, all of our fire stuff is all farmed out. But for the purposes of meeting the requirements of this unit and the subject, you've got to cover some fire safety and fire detention systems. So we can design the detector layout in accordance with this. So either at a 7 meter grid or at a 14 meter grid, and that will probably allow you to not have to have smoke detectors within your kitchen areas. So you don't have to worry about specifying specific detectors for kitchen areas. And then there are specifics in regards to heights shown in the following diagram. But because we're asked only to provide the plan for level 1, that's all that you need to do. So it says for level 1.
So only level 1.
For only level 1 that you have to produce.
Smoke detectors.
Well, so it's for only level 1 within this project that we have to do the fire services plan. So do the life safety plan, which is about distances to exits and specified exits, and then I forget what it's called exactly in the project, but the fire systems.
Fire safety plan.
Is it fire safety plan? Is it? So fire safety plan. So in that fire safety plan, that's also just required for level 1 for this project. And so on that, you'll be putting in any fire extinguishers, any hydrants and hose reels, any fire signage, and any fire warning systems.
So do we need a sprinkler system or not?
No, we don't need a sprinkler system. So it's, I went through that all on Monday, and that's all covered in the video there for that. But because of the size of the system, well, because of the type of the building and the size of the building, and the fact that we have hydrants and hose reels, it means that a sprinkler system is not required.
Right.
There are, I can't remember the other aspects. So in terms of fire safety, the NCC is a little bit sort of choose your own adventure. You can incorporate a sprinkler system, which means that you don't have to incorporate some other systems, or vice versa. And it makes far more sense with this building not to incorporate the sprinkler system. So that was set out. That's set out in the video for Monday. But the other important points I covered on Monday was that it says that you have to have fire hydrants, and because we have our only access between the 2 floors is a fire isolated stairway, you're not allowed to be bringing fire hoses through a fire isolated stairway. That's because they jam the doors open. And if someone's fighting a fire and they realise, no, we can't get this out, and they just drop the hose and run out, that door won't close, fire spreads through the building. So because you're not allowed to run hoses through the fire isolated stairway, means that you can't reach the second floor with a fire hose, which then means you have to put a hydrant and fire hose rule on every floor. If it was a situation whereby we had one floor and then we had a bit of a mezzanine working area where we didn't have a fire isolated stairway between the two, yes, we could get away with a fire hydrant on the bottom and hose reel as long as it was enough to do the whole room. And then on the top floor, we'd also have to have a hydrant. But yeah, given the setup of this one, we have to have hydrants on every floor and fire hose reel on every floor. That hydrant, it's not a large piece of equipment. That's like the hydrants that you see around here, the 150mm pipes with the Storz fittings on them. Typically the big boxes you see around the place that say fire hydrant, they've got a fire hydrant booster within them, which is a pump system which provides pressure. So it sucks it out of a tank and provides all that pressure. We're not providing large boxes on each of our floors. We're providing accommodation for that pipe and the Storz fitting on it, and then the hose reel next to it. And the size, and you saw both of you saw the size of those hose reels, the one from Apex Fire. So there are specifications about the sizes of hose reels. There's an Australian standard for it, but you can also just research fire hose reels proprietary systems online, and they say our fire hose reels are designed as per AS, etc., and they will reach 36 metres for a 19mm hose. So they're the important design elements in regards to that we covered on Monday. So that's our spacing of detectors, and then we've got within the National Construction Code, Part E, for visibility in emergency exit signs and warning systems. So we've got our performance requirements around that, but then emergency exit signs and warning systems are deemed to satisfy provisions. And then we also got emergency luminaires, AS 2293. Now, because I'll go back and hopefully it's still active. Yes. Okay. 3.1.
I have been unsuccessful getting into the Australian standards every time I've tried lately.
That's weird.
The users, it's all used up.
Yeah, right.
Yeah, sometimes that happens.
Yeah.
But I just try refreshing.
I've tried a lot to do.
Yeah, I've been on there a lot recently. We've got 3 licenses.
Yep.
Yeah. Yeah, maybe it's just that time semester, but I haven't had any trouble getting on. I've got on every time. So, yeah, strange enough. There is. I'll see if I can dig it out for you later on. There's also there's that way to go through the library. So you go through online databases and click that link, and it takes you to it. TAFE also has an actual login for the Australian standards as well. I can't remember the password off the top of my head. I'll have to find that. But possibly, if you're having issues getting onto Australian standards, you need to push ahead with your work. You can go to the SAI Global website, use that login, and that might be your way of getting access. So please remind me after this, and I'll do that. So we've got NCC E 4.2 emergency lighting requirements. So an emergency lighting system must be installed in every fire isolated stairway. fire isolated passageway or fire isolated ramp. And in every story of a class 5, 6, 7, 8 or 9 building where the story has a floor area of more than 300 square metres. So both those things sound a bit like us. Fire isolated stairway and floor area of greater than 300 square metres. In every passageway, corridor, hallway or the like that is part of the path of travel to an exit. So you have 2 exits, you have a path of travel between your 2 exits, and in any room having a floor area more than 100 square metres that is not open to a corridor or space that has emergency lighting, or to a road or open space, and in any room having a floor area more than 300 square metres. So that's us. Again, in every passageway, corridor, hallway or the like having a length of more than 6 metres from the entrance doorway of any sole occupancy unit in a class 2 or 3 building. Well, that's not us. We won't. Yeah, we don't have any sole. Well, I guess yes, no, we do. So, in a sole occupancy unit in a class 5, 6, or 9 building, if the floor area of the unit is more than 300 square metres, and an exit from the unit does not open to a road or open space. So, yeah. So we need to have.
Sole occupancy unit that you're talking about in class 6, would that be those individual offices upstairs?
No. So a sole occupancy unit is any area of a building which is separated by a firewall. Because now I can't exactly remember, but it's going to be far easier for us to have our building as fire as separate floors or each their own fire compartments.
Yeah.
So we have to have that fire separation between floors. Because we're going down that route of having that fire separation between each floor then becomes a sole occupancy unit because it's
Right.
yeah. Or they can be tenanted out separately and used separately. So we treat each floor or each fire isolated component as a sole occupancy unit for that purpose. Yep. So yeah. So we have to have one in every fire isolated stairwell or stairway, and in every story, in every passage, corridor, hallway, or the like that is part of the path of travel to an exit. A, B, and also F to. Oh yes, we covered F. Any point on the floor of that story is more than 20 metres from the nearest doorway leading directly to a stairway, ramp, passageway, road or open space, or egress from that story involves a vertical rise within the building of more than 1.5 metres, or any vertical rise in the story concerned does not admit sufficient light. So so we have that, yeah. So we have points on our floor that are more than 20 metres to the nearest doorway, leading directly to a stairway, ramp or passageway. There are also,
And that 20 metres,
yeah.
is that as the bird flies or is that actually walking around a path?
That'll be walking around a path.
Okay.
So yeah, because although as building designers we cannot determine where exactly they're going to be putting their furniture, I guess we should be try to anticipate that and visualize those things. What we've got on our building is building like this, stairs here, and then we'll have probably desks and whatever here. I dare say that everybody is going to be using that area there as a passageway of sorts. And we'll go into the Australian standard bit about the visibility of them, but we can be fairly safe. This is going to be a passageway, and then we've got some paths of travel or so here, but we can say this one's going to be a path of travel. So what we'll need to have is, things that are visible here, and we want those things to be visible from everywhere in the building. So we want, because it's not just that we want this exit to be visible to some people, this exit to be visible to other people. Both exits need to be visible because they have to have that option of 2 exits. So we'll have those visible, but because we've got distances more than 20 meters, I'm suggesting we should also have an fire exits signage there as well. So we've got, but we have paths that travel more than 20 meters, so we'll need to have that signage there. And there we go. So into the Australian standard. So the Australian standard for this is AS 2293 Part 1, and we've got Part 4.5 is the section dealing with locations. So Part 4, Section 4. That's frozen up on me here. Alright. So I've got exit signs, Part 4, and then back, since this one's frozen up on me for now, I'll just give it a bit of time to think. Oh, the whole thing's frozen up on me, right, that's great. Well, yeah, I haven't been able to get, for some reason actually, the issue seems to be tied up with this Australian standard, so I won't be going, so I won't go through this Australian standards, the issues, because when I've been clicking on this, then it's been causing other issues with internet, so we'll just go back to the NCC. The part within Australian Standard 2293, which I was going to show, was Part 4.5, which relates to locations. So that's locations of exit signage. Within that Australian Standard, it sets out various different luminances, etc. Like you have to achieve this particular sort of luminance. So we're not going to be touching on that at all. You purchase your exit signage, and you check that it complies with the Australian standard for its manufacture. So the electricians installing that signage, they will have to purchase the correct signage. But the locations is something we touch on. That's covered in Part 4.5. The area, though, from the NCC, which also relates to location of the signage, we've got E4.5 exit signs. The bits we're concerned with is an exit sign must be clearly visible to persons approaching the exit and must be installed on, above or adjacent to each door providing egress from a story. So you've got doors providing egress from a story. An enclosed stairway, passageway or ramp serving as a required exit. Well, for us that's the same as this. An external stairway, we don't have one of those. External access balcony leading to a required exit, we won't have one of those. No, we won't have one of those. And a door from an enclosed stairway, passageway or ramp at entry level or a discharge for road or open space. And so when we get down to that bottom floor, we want to have where we have to go outside from the fire isolated stairways, we want that exit sign there as well. Not that you have to show that, because you're required to only do these plans for level 1. So it's about specifying the locations for level 1, but beware, if you were to do the whole building, we'd have to have them within inside that stairway as well. And then we've got E4.6 direction signs. If an exit is not readily apparent to persons occupying or visiting the building, then exit signs must be installed in appropriate positions in corridors, hallways, lobbies and the like, indicating the direction to a required exit. Hence, with our plan here, if these aren't going to be very visible, then we have some signage to say that the exits are that way. That way we cover all bases, because we're within 20 meters of travel from each other, and then we're also visible from any point in that floor. So that's the exit signage covered. And then of course, as with all things on these plans, you say exit signage to comply with AS 2293 Part 1. So it covers all the luminance and so on, and the requirements around battery backups and all that sort of stuff, because of course we can't just have exit signage which is just hardwired in with no battery backup, because if we don't have battery backup and we have a fire, the first thing to go out is the power. We want those exit signs to be visible in the event of that blackout. So that's all the fire safety requirements covered. Then in regards to our lighting, so I've got in here for our project 3 in building, if we click on that, head down to here, we've got project 3 electrical. So this is to cover our lighting. So there's just a bit of background, and for all of you that did Certificate 4 Materials and Methods, this should be fairly familiar to you. So you would have been through this before. I haven't changed the example at all. So we have that exact. So this is the same information you've had previously, talking about light versus lumens. So just as a bit of a recap. So yeah, the amount of light emitted from a globe is measured in lumens. An efficient lamp will provide the same amount of lumens lighting with less energy, as in expressing watts, compared to an inefficient lamp. So previously, for us old enough to know, you used to have incandescent globes, and you go, oh, I reckon we probably want a 25 watt here, a 40 watt here, a 60 watt here, a 100 watt here, and you make your decisions based on those wattages. Now it gets a little bit more complicated, and you probably spend about 5 minutes in front of the light globes in the supermarket going, oh, light versus lumens versus price. It's quite a bit more complicated. But now you're choosing lights based on their output. I'm not expecting you to go into a great deal of research to go, oh, I can provide these lumens at this particular wattage. This Philips light globe or whatever gives me the best conversion for that. No, we're not so much interested in trying to find the most efficient light. By all means, do that if you wish, but it's about finding lights which will fit into your grid type ceiling. So I suggest having a suspended ceiling with acoustic tiles that happen in those 600 by 600 grids, because this is going to be the simplest for you, and it's a very common ceiling system for an office situation. And when you're dealing with ceiling grids of 600 by 600, you can easily incorporate lighting bays, your standard size lighting bays, which are 1200 or 600 lighting bays. These ones, 1200 lights. But you've got, we don't have them in here, but has everybody seen those lighting bays? But it's so 1200 by 300, or sometimes even 1200 by 600. We've got two of them together. They're just a large rectangular bit that if you take the diffuser off, you've got a whole bunch of fluoro tubes in there. That when those fluoro tubes go out, take them out, put new ones in. So that's the style of lighting I would expect you to put into the office. By all means, you can get creative and put something else in there if you wish. But I think that's probably going to be the easiest if you go with a suspended ceiling with a grid and you put your lighting bays in that. So choose some lights, record what their lumens are, then go through and calculate what your lighting requirements are. So the example in here sets it as we're choosing 240 lux. Now I'll try to make this a little larger so we can see it a bit better. No, okay, that plus is not working on this one. Does this one? Oh yes. Does that work? So that's for ordinary or moderately easy. School chalkboards and charts, medium woodworking, food preparation, counters for transactions. So it's doable, but I think probably the more appropriate is 320, routine office tasks, etc., reading, writing, typing, and inquiry desks. That's probably the classification I'd be going for with our level 1 office. Either one, I'll accept either one, of course. But what you have to do is put your calculations in there. So say we've got this many, well, as per the Australian standard, we've got this many lumens, and then put that in there for calculating your total lumens. Because with this building we've got a great deal of glass on that front facade as well. We've got a lot of natural light coming in there as well. Possibly we don't need to go over the top with our lumens required. But we're going to be at 240 or 320. The example uses 240. So our equation for calculating illumination is, so illumination, our lux, so our lumen per square metre. So if we go for 240 lux, so 240 lumens per square metre, is illuminance per lamp, that's fairly simple, times by the coefficient of utilisation. So how much of that light is actually being reflected back to the person who's using it. So we've got some, you've got some light coming off here, and how well is that light going to be coming back to me? So if I stare at that light, that's going to be really bright in my eyes. I'm going to be, getting 100% of those lumens if I stare at the light. If I look at a piece of paper, I get less than 100%. So that's our coefficient of utilisation. And our coefficient of utilisation is 0.6. So from that, 100 comes down here, I get 60 back. And then our light loss factor. So our light loss factor, that's going to differ. If we've got lights, let's say we've got our office down there in the corridor, and we've got our lights right up there on the sawtooth ceiling. If I have 1,000 lumens on that sawtooth ceiling, by the time I'm working at the floor there, I'm not going to have much light. If I've got 1,000 lumens here, I've got plenty of light. It's about the amount of light which is lost over that distance as it becomes further diffused. So that just assumes a standard sort of ceiling height situation. So we've got light loss factor of 0.8. So it's all that divided by our floor area. So that's fairly much the things you have to decide on is how many lux you want to go for and what your floor area is. So you choose your floor area in that office space. You go, this is our floor area. And you put that into the equation. Now, all the algebra has been done for you in this regard. So, because we want to separate out that lumens, we want to work out what lumens it is. So, if we interpolate that equation to separate out the lumens, we've got our floor area, 250 square meters, by our lux that we've chosen. So this we work out, this we choose, divided by 0.48. And that 0.48 is 0.6 times 0.8.
Are they always going to be about that, the 0.6 and the 0.8?
Yeah. To actually do lighting design, once again, like fire systems, shop it out, because there are people that specialise in this, and this is very simplified, dumbed down. Not to say but it's a very simplified approach, because if we were to teach you lighting properly, well then that's a course in and of itself. So this is enough to be able to make those decisions and to think about, what sort of things are we going to require? But for your general office, that's a fairly good guide. And same goes for any of the air conditioning stuff that you've covered in this subject as well. Air conditioning is actually really complex to go calculating, but there are some just really simple sort of roundabout ways of getting an idea, and that's what we do here. So if we were 250 square meters and we were after 240 lux, the lumens we would end up wanting is 125,000 lumens. That would be it. But that's not the answer. Right, you guys work through that answer, calculate your floor area for your office space there, choose whether it's going to be 240 or 320, get your lumens, and then research, like find a fluorescent globe. And so how many lumens are these fluorescent globes going to put out? How many of those fluorescent globes do I have in a bay? you know, do I have 2 in a bay? Do I have 4 in a bay? Have a look at that, or 3 in a bay, and then work out how many globes you need, and then see about spacing those about your office space, and then draw up your reflected ceiling plan. In regards to how we think about a reflected ceiling plan, the best way I think to think about it is, like every other plan, we're viewing them from on top. If we draw a floor plan, it's as if we're standing over it and we're looking down on it, and that's our floor plan happening there. We do the same with our ceiling plan as well, except if we were to look at the back side of our ceiling, we'd just see the back side of our lights and all the hangers for the suspended ceiling and so on. That's not what we want to see. We want to see that underside. So you imagine there are mirrors on the floor, that you're actually looking at that mirrored version. So that reflected ceiling plan has exactly the same shape and outline and orientation as all your other plans, but it shows things from underneath. Does that make perfect sense? Cool. And if you're going to go with a suspended grid type ceiling system, like a rondo acoustic tile ceiling system, I'm not sure how you go about drawing that up in Revit. Possibly there are some ways in Revit to go drawing it up. How I would do that in AutoCAD though is to just get my internal walls, choose this wall, and then offset by 600, and then get my first grid point, and then offset that by 20 millimeters for my my hangers for the acoustic tiles, and then copy that across, and in 30 seconds or so you've got a grid set out for your acoustic tiles for your ceiling. And then, because a lot of these office lighting solutions are based around the idea of those acoustic tile grid ceiling systems, they're all just the right size to just drop in to those things. So that's how I'd if I was doing it, I'd do it in AutoCAD and bring it in. But maybe there are simple ways in Revit, if you guys know. And because I don't know about how the Revit stuff works, and this is sort of something that you guys haven't touched on a lot, if any of you know how to do those ceiling plans really easily in Revit, by all means, let me know. I'm keen to share the info on that. Does anybody know how to? Has anybody done a ceiling plan in Revit before?
Just the one I told you about.
Yeah. Yeah. Just that. Yeah.
Just that one was, yeah, Russell showing you.
Yeah.
Step by step.
Yeah.
But I don't remember.
Yeah. Yeah. And also further to that, looking in the model earlier on with Mary, there's a grid type ceiling system in that bottom floor already. There's a bit of that. I don't know if you can copy some of that and use that around. If you've got issues with actually producing the plan, let me know so we can go around. But apart from whether you guys have issues with that ceiling plan, this seems to be the simplest approach to approach both electrical installations and lighting installations. And it's something that you will do in industry. You will be doing reflected ceiling plans.
Scroll up for a sec. Just
Yep.
slightly.
Sure.
Thank you. It's all I need.
Yep. So all of this is all included there on Learn for you to open up at home. All right, and that's it. So I'll send out that email that I meant to send out earlier on today as well.